And I get a lot of mail. Why I'm not being allowed today? Hey, you too. Did you get it? Okay, Ken, let's start.
All right, it's party time?
Yep, party time.
All righty, let's do this. I'm on the screen.
Yeah, you're on the screen.
All right.
You're just facing me because of the VGA cord is quite short, so I can't move my laptop around.
Okay, so I'm just presenting to you personally right now.
Okay, we can get a few guys behind. Let's check it out.
Okay, no, that works. Hey, everybody. My name is Ken Wheeler. I'm the director of open source at Formidable, where we do a whole lot of React stuff and Node stuff, all kinds of stuff. And I'm here today to talk about writing React with ReasonML. And bear with me. It's 12:35 a.m. in New Jersey, so I'll try and keep it lively. So I'm gonna go ahead and share my screen here.
Okay.
So hang on, business going. All right. Yeah. So got a little slide deck here that we get started off, right? Creating ReactJS with ReasonML. Right? So a lot of you might be wondering, what is Reason? If you, I mean, I hope you guys have heard of React, or at least seen it before, because there's going to be a little bit of that going on. But you may not have heard of Reason, but it's fantastic. What it is it's a syntax and tool chain for OCaml. If you've heard of OCaml, this is a syntax on top of it, right? So you're still writing OCaml, but in this this new fancy syntax, as well as the tool chain to make development a lot easier and a lot more fun. So it's a new familiar syntax for the battle-tested language that is OCaml. Right.
Can you just increase the font? I mean, the size of that?
Sure.
Yeah, the screen.
Yeah. It's a workflow for compiling to JavaScript and native code, and a set of friendly documentations, libraries, and utilities. So you might be asking yourself, why is this cool? So first off, it's a fun new set of language features, especially if you're coming from JavaScript. It's a set of features that I wish were in JavaScript, but they're not. So I like to write things in Reason these days. It's got a great type system. The typing is phenomenal. And one of my favorite things is that you get your errors at compile time. I know obviously there's still errors that can sneak through on the browser, but generally speaking, getting those errors at compile time is pretty helpful. So let's check out some of the language features of Reason before I get into the whole JavaScript thing. So that also it'll make some of the coding exercises a little bit easier to follow. So one of the first things I want to talk about is let binding in Reason. So up top here, you can see like let a equal 5, right? And then a just equals 5 right here. That's a regular let binding, but you can do a little bit more with this. So you have let b right here. And then inside of this bracket, you could define c and d here, right? And then you're returning c times d, right? But outside of this, c and d aren't available. Right, so this let binding creates these little scopes, and that's fantastic. Next thing I wanted to look at here, let me see if I could get rid of this little Google window, was the typing, right? So it does inferred typing, but you can also explicitly type things. So the first line here we can look at, you say let a equals 5, right? Because you're setting it to a number, this can be inferred as an int, right? If you wanted to do it explicitly, you would have, let b int equals 10. Right? When you have something like down here, like a record, right, that requires a type declaration. So up above that, I could say type person, and then it's going to have this record shape of age, int, name, and string. And I could say let Ken equal age 32, name Ken. If you if I tried to put like string 32, it wouldn't work here. So this is pretty cool. Functions in Reason. So if we look here, this is a function declaration. I say let add, which is our function name, and then you have your arguments here, a and b, and what you're returning is a plus b. So then if you were to call this function, you would say add, and then your two arguments for a and b, 1 and 2. That returns 3. A pretty cool thing if you're not into the whole positional arguments thing is you can have labeled arguments here, right? So this one, let full name, you say let full name, and then you can label these so order doesn't really matter. So first is first, last is last. And then what you're returning is, this little exponent symbol is string concatenation in Reason. So you're saying, first plus string plus last. So then you could use it like here. You could say print end line, and then say full name, first is Ken, last is Wheeler. You could say last is Wheeler, first is Ken, but they're labeled, so it doesn't matter the position. Probably one of my favorite things in Reason is the pattern matching, which is extraordinarily expressive. What you're seeing right here is a key handler, right? So you feed your your key codes into here. So it'll switch on key, right? So you have state and you have your key, and this is going to be the key code that comes through. So the pattern matching in this switch is essentially saying if your key code is 27, in this example, you get rid of whatever was drawn there. And if it's, like, I don't know what these exact ones are. Maybe it's like plus or minus or something. But yeah, it'll set the brush size up and down. And then this is a no op for everything else. So this is like a default. So pattern matching is really, really nice when you're coding a Reason. It also has destructuring. So if we do a thing like we did before, where we create the type and then create the record here, like in ES6, you can destructure right out of there. So I could say let name and age A equals Ken, right? And then these are in the global scope from that point forward. Modules is probably the coolest thing. Let me see. Yeah, that's fine. So a module in Reason is like a little namespace. So here I could say module math, and then in here make my declarations. I can define this add function, and then this is actually kind of cool. So it kind of like auto curries functions. So I can define this function, let add 5 equal add 5 like this, and then you say down here add 5 5, and it'll kind of auto curry that for you. But in the context of the modules here, you can access it with dot notation. So if you have the math module, I could say math.add5, and that's how that works. Also, you can have like this destructuring scope of modules, where you could say math dot, and then in these brackets, have access to anything that's inside of math, kind of shorthand style. So I could say add 5 10 here. Additionally, you can open a module. So down here, you're seeing when you say open math, what that does is that spreads this module scope into the global. So add 5 is now available in the global scope after calling open. And we're gonna use some modules, and it's pretty fun. So I'll get to that in a little bit. So you might be wondering, how in the world does any of this crazy business work with or relate to JavaScript? And that's what I'm here to tell you. There's a project called BuckleScript by the good folks at Bloomberg, and what that does is it compiles OCaml code to JavaScript. And you can use that also with Reason to compile your Reason code to JavaScript. So you can write a lot of your JavaScript, in this code, and it actually outputs fantastic JavaScript. So if there's something that you want to use that doesn't exist, you could do some interop. So this is an example of some interop here. If I could show, I'll see if I can bump this up a little bit.
Can you see? You need to bump it a bit more.
I don't think it's bumping much more.
Okay.
Is it getting bigger on your screen, or is this just zooming on mine?
Just static actually on our screen. Move a bit. I can just see JS interop, and that's it. Vibration, vibrate, but that's me looking into my laptop screen. But on the
this is
can I go ahead? I mean, you all want to go ahead and watch out? I mean, so being a backbencher, you all can see. Yeah, you can see. No, how about you? Then you all go ahead and check out, man. Don't be backbenchers. They ain't college.
Yeah, so I mean, this isn't a super important part anyway. It's just showing the interop of buckle script. So this is a camel code where you're gonna where you can define. What's that?
Okay, no, cool. I mean, I got the guys to go forward. Just like Moses.
Yeah, so if you have something in JavaScript, like this is the Vibrate API from React Native, you have vibration.vibrate right here, and then you have vibration.cancel.
Okay.
Right? So if you wanted to bridge those, right? So you wanted to create JavaScript interop for OCaml. If you wanted to write this in OCaml, you would define these externals here, and this is for buckle script, right? So like here, right? You have cancel. So you say external cancel, right? It returns and takes unit. Unit is unit's like null. So it takes null and returns null. And then here you say your BS scope and your BS module. So you're saying in the module React Native, like import React Native, and then in vibration bridge over cancel. So as long as you define kind of like the signature for it, then you're able to use it. So it knows what it's expecting. Good. So now that we've seen that, let's talk about how React comes into play, right? The same folks that make Reason, the good folks at Facebook, also make React, and they also made Reason React, right? Which is React bindings for Reason. So if you were to take a regular React component like this, right? You have export default class page extends React component. You're going to return a div here. Inside of it, you're going to print out this.props.message, right? You give it a display name, give it some prop types. Message is expected to be a string. This is React code right here. In Reason React, this is what it looks like. So we're talking about modules before. You define this module page, right? And then you include React Re-component. What this does is it takes React Re-component stuff and puts it in the scope of this module. So you have render, which would be React Re-component render, etc. So in here we're saying type props message string. So you're defining props shape right here. Then you define the component name right here. And then in render, the render function, you can actually write JSX right in Reason. So I have my div here. I do a string conversion, right? So I take the props.message string, call React restring to element. And then down here, you're including React recreate component. So you're creating your component here, and then you do this, which wraps the props. And that's all there is really to it. That's how you can write this in Reason. So let's look at some examples. First of all, before I get to the examples, I just want to say, if you want to look more into Reason, you can go to the page right here, which goes into way more detail than I was able to just now. You could look at you know, all the stuff that it can do. I just focus on a couple things, but, you know, fun stuff like tuples and, you know, all kinds of really fun stuff. And then you can get a little bit more about getting your environment set up, etc. So the first thing I want to take a look at code-wise, my good friend Matej Satorsky just put together a project here, Create Reason React App. If you've used Create React App, this isn't that similar in the sense that it's not a CLI utility to, you know, generate a boilerplate. This is just a boilerplate that you just clone. So you can go, you clone this down, and then npm start, and you're good to go. You're good to get rolling. So I want to just take a look. We could show how this works a little bit. Bring this Google Hangout business over here. So my npm start here. We can just take a look at what this actually does, right? So for our dev dependencies, we have BS platform, which is important. This is the buckle script builder, Webpack, and Webpack dev server. The other important thing here is you have React, React on, and Reason React. All right, so you're bringing in Reason React right here. Your actual scripts to make this work, there's two of them. So you have npm run dev and npm run bsb watch. So dev is just Webpack dev server, right? That if you're looking here, now you have your lib stuff right here, and then over here in public, it's looking for build main.js, and then if we go, it's got your entry right here. Is this font size okay? Or you need to bump that up?
I think so. There's a max we can go. I think so. We strain our eyes, but you can go forward.
I could probably bump this up a little bit.
I think so.
Yeah.
Is it visible now for you guys? Just bump up a bit more. Just one more. Control plus. Yeah. Okay.
Now we're talking business. Okay. Yeah. So if we look at the Webpack config here, you're setting the entry to this lib folder, right? Lib.js src index. And what that actually is index.re when it gets built. So if we're in package.json, we're able to say, we're able to look in here and say, you have Webpack dev server running, and then you have BSB watch right here. So you have BSB make world. We look at our buckle script configuration, and here's where you specify your dependencies, Reason React being the most important one. The other one to take a look at here is sources, right? So this is going to say, where are we going to look for files to compile, right? And we're saying src right here. So it's always going to kick out to this lib folder. So if we look here at like index.re, you know, for React re render to element with ID. So you're rendering your app here to root. This is like a React DOM.render. This is actually what gets generated right here. So it's very human readable. So when buckle script generates that, it's going to require app. It's going to require this curry and React DOM and then just kick this out right there. So the generated code is pretty nice. And that's how that all comes together. If I click Chrome here, this is what this looks like, right? So we have Create React Reason app right here. You have this business right here, your spinning logo. Let's take a look at how that works. So index, all this does is kind of just renders app right there. And here's your app. Worth mentioning and acknowledging right now is that in Reason, there's no imports. So right here, I'm able to say app and reference it. I'm never importing or assigning this, right? That's here, right? So with the OCaml module system here, how this is set up, you don't have to do any imports. So you don't see any, you know, import this from that at the top, none of that. You know, you're just writing it out. Yeah, so to look at what's going on here, so we have our module. We include React Re component. It takes props title, right? If you look here, this gets passed in the title prop right here. I could say, yeah, welcome to, hey, what up though, right? Hit save. Look on our terminal here, it just finished compiling. Hey, what up though? So if we head back over here, right, you have props, title, string. It's got a name. This is a handle click method right here. So it doesn't really take anything right there, but this is an example of JS interop, right? You're saying js.log and then passing clicked, right? Doesn't return anything. It looks like on the header here with that SVG with the logo, if you click that, that's what calls your handle click right here. So if I bust open a terminal here, you click that, you start to see clicked down here. So you can see that that's all working. So yeah, I mean, inside of this render function, it is pretty similar to what you would see in React, right? You're writing JSX just like this. You have your updater, right, which is going to call the class or module methods, rather. Down here, you have an inline SVG, which is that spinning logo. You also have CSS in here that's making that spin. It's all class name CSS. There's not really inline styles here. There is inline styles here, where you call style.make. And this is how you can put an inline style on, let's say, the H2. So if I were to say like font size 2EM and then bounce it to 4, this will get considerably larger. And then down here, yeah, you can just see the P class name. Anytime you use a string is actually a text element in React. So you need to call string to element in this particular setup. So yeah, this is the long and short of how you can get set up pretty quickly on the web, making React apps in Reason for the web. However, I thought a more interesting example would be to do it for React Native. So I'd like to show how that works real quick. All right. So here is a React Native project that I am writing in Reason. So the first thing I'm going to do is npm run iOS. Right? So this is a create React Native application. So I can run it on my phone with Exponent, but I want you guys to be able to see it.
Okay.
So I'm going to pull up a simulator once this packager starts, and we can have a look. So while this is starting, this is a very similar sort of setup to what's going on in the Create Reason React app for the web. I have this app.js here, and I'm importing from that same lib folder where BuckleScript is compiling to, and then exporting it default, which is how that works and for the Exponent-based apps. So my simulator's popping up here, and we can have a look at how a couple different things work.
Okay.
I have a couple different little app examples that we can go through, so we can see how different things would be achieved when writing Reason. It'll load, I promise.
Thank you.
So while this is loading, I'm going to go over to my other shell here and start up the BuckleScript watch. So you'll have both of these rascals running. Wow, this is taking a little while here.
Yeah, what's up?
I don't know. iPhone simulators, man.
You use Visor? Have you anybody used Visor?
Hmm?
No, I use Visor. I mean, you just, but this is an Android. We use this debugging.
Uh-huh.
Yeah. Okay, done. It's up.
Yeah, this should pop up pretty soon.
Yeah.
So we have the Expo app here on iOS.
Oh yeah, you doing Expo? Even I'm going to use Expo Snack.
Yeah, Expo is pretty much the best ever. I'm a big fan of Expo.
Use the Snack one? I mean, what you used to call Sketch before?
Yeah, I use Snack all the time. Yeah, absolutely. I mean, this is with Create React Native app. It kicks out this like ANSI QR code right to the terminal. You can scan it. All right, there we have it. Okay, so I'm gonna pull this back just so we can see this. All right. Right. So here is our main app here. Let's take a look at the absolute root. Right. So here is your root. So if you're gonna import a generated component into JavaScript, like we're doing back in app here, where we're importing that, one of the most important things to do is specify this JS props right here, so that it knows that this is going to get bridged and will have interoperability with JavaScript. This actually doesn't have any props, but you still have to include this stuff here as if it did, just because this is the interop point with JavaScript. So this doesn't really do anything other than render whatever I tell it to, right? So unit, again, is like null in Reason. Doesn't have any props, doesn't have any actual props. It has a name, right? But all render is doing is rendering this component home here, which you can see here just says Reason is awesome. So again, this isn't doing a whole lot here. You don't have any props or interactivity or anything. You're just rendering a view and text, right? So I say, Reason is awesome. I could say ridiculously awesome and hit save, and this will update, and you'll have that there. And you can do all kinds of things here. You can go in and say background color is FFCCOO or something like that. One thing that I don't think I actually touched on is how this style works. So style here, so you have view, you have text. Again, there's no imports at all. I just open React Native, which takes the React Native and spreads it. That's one thing that I might want to touch on real quick, is that I included the BS React Native, which is the React Native buckle script bindings. And then you add that here in your BS config, right there. And that's how in home here, I'm able to say open React Native. And then you have view and style and text all available to you. So I'm saying I'm not defining like a style up here just because it's like one element. I could just do it inline right on it. So I'm saying style equals style. And this is what we saw before. When you have a style module, normally if you didn't do this right there, you would be saying like style.background color, style.flex, style.justify content. What this syntax does right here is it creates this scope here. So when I say style dot and then the brackets, you're saying anything in here, you can assume it would be prefixed by this, but it's not anymore. Then you have this, which appears to be an array, but it's not really an array. It's a list in Reason. So you have this list of styles. Here is a string value for background color. All your like like what would normally be like 1 is a float, right? So all the numeric values here are floats. And certain things like justify content and line items where they're gonna take enums is you have this sort of enum setup where it's this backtick and then center, right? You can't just pass in strings for that. It's got enums of what it's what the acceptable values are, and you'll get compile time errors if you try and put in something else.
So if you,
just to show you
put something like a flex, flex end, flex start, or like something else other than these, it will throw an error or what?
Oh yeah, and that's the coolest part about this, is that you get compile time error. So if I pass in a raw integer here, this expression has type int, but expression was expected type float, right? Or I hit that, and we're all good. Here I could say justify content, try and pass in a string here, center. And this expression has type string, but expression was expected of type center, flex end, flex start. So you said these are like enums.
So that's like flex end is also in camel casing.
Yeah. So everything's camel cased. There's no dashing taking place, and the same applies here for your enums. They're not strings, so you would pretty much anytime you're going to have a dash, you would just camel case it, and you're pretty much good to go. Yeah. So this is the first example of just basic styling, basic layout. If we head back to the root component here, I can swap this out with something else, and we can look at something a little bit different. Having like a one view laid out is sort of fun, but it's not that fun. Maybe we could do something a bit stateful. Right? So a little statefulness and a little interaction taking place. So if I pull up stateful here, I'll just pull this down for a second. One thing that we're going to see here is we're actually creating our styles outside of the module because we have multiple of them, and now it's easy. So you could say let styles equal style sheet create. You're going to have style right here, and then you pass. It's a record right here, so you have you can name it like button and button wrapper, and then that's going to equal this style list definition here. Down here, anytime you have a component that has state in Reason, a lot like we did like JS props before, you're going to add stateful here. Right? Still doesn't take any props, so props are unit, but when you want to add state to a Reason component, the first thing you do is you define your state shape with a type. So I say type state count value is int, right? And then get initial state, which is what sets it from the get-go. We're going to say count value equals 0. If you haven't figured out by now, this is just a counter right here. So we can count up and count down. And the way that's accomplished is through these two methods here. Handle increment, handle decrement. It has state here from the updater, and it just returns your count value +1 or -1. So again, you're going to see down here, before we had render and it just had like kind of like a no op there, like it's just an empty argument. Here we do have arguments, and they're going to be state and updater, right? So state comes into play right here. So I say text value is string of int state count value. Because this count value is an int, but the text is expecting a string, we have to do a conversion right here. So you do string of int. We do have an inline style right here in the main view. And then down here, we have a view right here called button wrapper, right? So you have styles ## button wrapper, right? Which is how you're accessing this right here. You have to put a wrapper around these if you want them inline. So I say flex direction is row, and then that puts them inline like that. And then down here we have 2 touchable opacities. If you've done React Native, a touchable opacity is like a clickable layer, and when you click it, I don't know how the video feed is, but it does kind of like this little animated like half opacity thing. And it has an on press. So anytime you press this, this gets called, right? So you have your updater, and you're sending this method as the argument to the updater. So for the minus button here, you're sending decrement. For the plus button, sending increment. Right? Both of these have style button Right, so if your button style right here, your background color, I can make these same kind of fun orange color if we want to. Have a good time. You know, if we have this text right here, maybe we want to make like a style for it. I could say, yeah, make it like a big thing, right? So I could say, you know, text and style. Oops. Wow. And then font size. Remember, we got to use ints here, right? So you just say 32 dot. All right, that should be all good. And then here we're going to say style equals styles text. Do we have a failure here? Oh boy. 15. Something different. Trying to figure out the origin of this. So 18. Oh, yeah. I'm very silly. There's yeah. Oh yeah, now it's gonna fail because it's not a float. I'm just being very silly here. Okay, yeah, now so it's pretty good size now. Let's make it friggin' huge. Looks like a legit counter. Wow. So yeah, as you can see, this compiler really nips everything in the bud. If there's an error, you're gonna know about it, which is good. Yeah, so that's a good overview of the stateful components. Let's take a look at something else here. So let's have a look at some iteration. Right?
Can you see the screen?
So as developers, a good portion of our day is fetching data and rendering a list of it. So I'm going to show you how to do that. So this is a list here. So I say let people equal a list of strings. Ken, Rob, Brian, Steve, and John. That's the name of me and all of my brothers. So we're rendering out the whole gang here. This, like before, is just a style sheet declaration for your container, each list item, and the text inside of that item. So this doesn't have state or JS props, so this is just a regular React Re component. Render, again, doesn't have any of that, so it's just kind of like that no argument style. So what we want to do here, which is interesting, is we want to render this list out. So iterating over a list in regular React might look like something like this, right? Where you'd say like, I would say like people.map person, you know, return, you know, li, person.name or something like that. And that's how you would iterate over that in like regular React. Here in Reason, first of all, anytime you do like the interpolation, you're gonna use your parens to break into that. And then you're gonna say list map, right? You're gonna have a function here, which is your map function, right? P would be, you know, the individual person and people. And then you're returning a view, right, with the list item styles, which is gonna be like that margin and everything. And then your text, the value of which is P, right? So for each one, it's gonna get the text value in there. And then your style is the text style. And then the second argument here is people piped to React Re list to element, right? So when you're sending out this list here, yeah, it is returning a list type right here in the middle of render. So you need to call React Re to convert that to an element. Very similarly to how you have to do that with a text element in you know, when you have free floating text. Here in React Native, there's no such thing as free floating text. Text is always handled by a text tag because there's an instance of UI text. It's not like the web where text just lives out in the open. You know, you're not going to see that, but you will see this still in React Native. And yeah, iteration, that's pretty much all there is to that. So I have one more demo left, and it's arguably the most complex demo, but it shows some pretty cool stuff. And this is your navigator. So this is all fun and games, but when you're actually making an app, you have different screens, right? So how in the world would this actually work? So let's have a look at this right here. So we open React Native, we open React Navigation. So React Navigation, if you haven't seen it, is a very, well, it's probably the leading navigation right now that people are using React Native. So there is a, that should be in my scripts here. Maybe I just didn't save it in there. But yeah, I installed the bindings, and then if you go to the buckle script config, you have BS React Navigation bindings right here. So it's yeah, anytime you want to use one of those external libraries, you install the bindings or write the bindings, and then you, if you're installing them, you have to put them in the BS dependencies for the buckle script compiler. So with React Navigation, what this does is it lets you navigate here. Right? So it gives you different screens, this top bar, all that jazz. Let me show you how this works here. Again, we have our style sheet, just like we had in the other ones, getting defined. We define this type here, right, for the example list. Really, all we have is the one, right, which is the navigator screen. So it's got a name, and then the screen returns navigator screen, which is this component right here. Again, if we go here, right, all it says is, hey, look, I'm on page 2. And that's pretty much all this does right here, is it returns this. So in here, you're configuring you know, what's going to go here, returning that component. Then down here in the navigator module, with this stack navigator, you're not including React Re component, you're including stack navigator component. Okay? So it has some special stuff like main screen here. Main screen is what your initial one's going to be. So you have a scroll view, and then here I have touchable opacity, which is this button right here, and the view and the text. Right, the text is you know, navigator screen right here. The touchable opacity, which is like the clickable portion on press. You're saying navigation.navigate. You're passing navigation. You're passing your route name, navigator screen, right? Then down here is where you do your route config. So I'm setting up example routes right here, where we take that list, map over it, you know, return this right here, which is the route name, and then you know, a route config constructor with the screen that gets passed as well. The screen comes from the list you're iterating over. Your title is the route name. So when you click here, navigator screen is the route name, so this is the title. I could change this to, you know, anything we want. You know, I could say like, you know, test, you know, whatever, and then that's where we're going to end up here. But you probably don't want to do that. You probably want to keep that dynamic. You know, add something like that there. And then down here, you configure routes. So you say let routes equal, you have your routes config, you have your screen, your main screen, and then the example routes right here. And then your config, you set up, you have your initial route name. And that's all there is to that. It's kind of, this is probably one of the more confusing ones that I've worked with because it's pretty complex. However, you know, it's a pretty essential part of any React Native app is to have this kind of navigation set up. So I'm happy that this is bridged over and that I'm able to use it. Because now I could probably write an entire React Native app in Reason and not really have too much of a problem. So you might, at this point, ask, why would you do this? And when you have JavaScript and it works pretty well, why would you write this code right here? And I guess it's number one, I like it a lot. Number two, if you're writing, I feel like right now we're trying to make JavaScript do a lot of things that it doesn't do, whereas this does a lot of that. So we have some pretty elaborate systems around typing, or giving types to our typeless JavaScript, whereas you use things like TypeScript or Flow, which is cool, right? But this right here, this comes with types from the gate, inferred and explicit, and you get your compile time errors. So it's like having Babel and Flow on the next level almost. Plus, it's like a really nice functional way to do things. To take it a step further, you do need to keep in mind, while I am sitting here compiling this to JavaScript at the moment, OCaml is a systems language, right? So, I don't have to be sitting here writing JavaScript. I can write, high performance command line applications, systems programs with it. And not just that, but there's the possibility that someday you could write this and skip the whole JavaScript portion, and it just goes right to the native code on the phone. We're probably a little ways out from that right now, but I certainly wouldn't discount it. So, writing your code like this would give you a little bit of a jump on that. So, I mean, if you like, functional languages, you like, new kind of fun things, I would definitely recommend giving Reason a try. It's it's fun for the system stuff, and it's also fun for the JavaScript stuff. As you can see here, if you have an existing application with JavaScript, it's pretty easy to just drop this in. They did it at Facebook, and they rewrote, I think it's like 30% of the Messenger app is written in this, and they're having a good time with that. Yeah, Cheng Lu, I think, wrote a considerable amount of the Messenger app. It might even be higher at this point, where all that code is written in this right here. Not React Native. It's a web messenger. But still, yeah. So I think that's all I got. I don't know if you guys do QA.
Yeah, just hold on. Let me on the lights. Can you on the lights? Cool. Okay. Cool. So you can see me now.
I sure can.
Yeah. Okay. Cool. Let me also take you around of the bit of the thing, so you get to know that who you have been speaking to, right? Just
sure.
Yeah. Here you go. Just take a round. It's like full house. You have operation to get Osama. This is how it seems like, right?
What's up, everybody?
Okay, guys. So I think so. We got a full crowd out here. I mean, and I think so. A lot of guys also having production in ReactJS in production. So, guys, this is the time to ask questions. Okay, the floor is open.
Guys, how is the module system? You said that you don't need to import anything, so all files need to be compiled, and then it sees what are the modules. And so,
let me share this. Okay, go ahead.
Hi, can you hear me?
A little bit, yeah.
Okay, can you repeat the question once again?
So can you talk about the module system once again? You said that you don't need any imports. So is it like, when you write your file, the module, that name cannot be repeated in another place? Is it something like that?
So so when you have the compiler there, it's going to go through and it's going to look for all of those files. So if you have one of those modules, it kind of just loads that into the general scope. Yeah, so you're not doing granular imports. If you define a module, like if you define module app, in any other file that you're writing that's adjacent to that, app is going to be available. But then also, if you if you wanted the interior of app to be in your file, you would call that open command on it, and open is what kind of like spreads it into the current scope. So that would be like the equivalent of like a destructured import almost.
Okay.
Hey, I had another one. So I was wondering how you do async.
I'm sorry, can you?
How can you do async? I mean, promises and stuff. And is there a concept of like async?
I'm sorry, you're getting like muted. It'll work for a second.
Can you hear me now?
Yeah.
So I was wondering how you handle async in OCaml, right? Something like async loading of components as well as normal async operations, like your like how you would do with JS and promises.
I think there's actually promises bridged, so you can use promises. If you look in the buckle types repository, buckle types is where they have a lot of the different bindings written out. I know that they have fetch bindings set up, and I've seen promise, but I'm not sure if promise is actually built in to the buckle script built-in interop, or if that's a separate package.
Okay. So if I were to use something like some other library that I would want to use, something like style component, so is that like possible with the bindings?
Styled components. I'm not sure right now about styled components, just because I don't know if tag template literals are possible. I know that there's been talk about setting up a styled components for Reason, but in current form, it would be definitely interesting because, well, you know, you could probably do it. It would just, I would have to see exactly what that destructures to. The binding would get funny, right? Because you're using a tag template literal right there. So whatever that desugars to is probably the way that you would write that out. So I mean, like doing like style.h1 is probably pretty easy to do the bindings for. It's just what's going to be next. Like you probably definitely pass it as a string, right? They don't have like template strings.
Yeah.
I don't think.
I also like to have to transpile the CSS into enums, I guess. I mean the OCaml enums for the styles, right?
Yes and no. The way that those things were set up that you saw there are that's specifically set up for React Native. And it's specifically set up for like the bindings to kind of work with the same way that Reason kind of works. So you're gonna have like those enums like that. In regular React Native styles, like it doesn't. I mean, it'll call you on it, but it's not gonna be a compile time error. It's gonna be like a runtime thing where it's gonna be like, hey, like, this is a bad value for flex direction or something like that. But at compile time, it's not gonna throw. But what's nice here is that when they wrote these bindings, they wanted it to throw at compile time. So that's why you have those enums for things like center.
Right. All right. Thank you so much.
Oh, thank you.
Anybody else? Going once, going twice, and sold. Okay, thanks, Ken. Do you want to stay for the next one? Sumak Barve is going to speak about his own framework, Underkick. You want to stay there?
Yeah, can I hop on the on air link?
Yeah, no, don't worry. I'll create a new broadcast. Give me a minute, okay? I'm going to shut this one out.
Sounds good, man.
Cheers, man. Thanks a lot.
Thank you.
Thank you.
Thanks.